This is a series of 2 movies where we will learn how to translate information into equations in the first movie and then how to solve equations in the second movie. These 2 movies deal only with linear equations. It is very important to translate information given by describing a real-life situation into what we call a mathematical model, using the language of mathematics and of algebra, translate it into an equation, then we can solve. Let us start with a very basic example. Please pause the movie and read the question. This is a very simple question, as you can see. I don't really need algebra to solve it, but we'll start modeling from simple situations. The way your brain works when you solve this question, even if you don't realize it, is that you think of a number, you add 7, and the number you end up with is 22. How do you find the initial number? We know that the inverse operation to addition is subtraction, so you do minus 7. The way I solve this using algebra, I will say I'm thinking of a number, I don't know the number, I call it x. So I will call x, let x be the number I'm thinking of. I'm looking in the information given for an equation. My equation is generally given by the word is. Is means equal. Result, my equation is result is 22. What is the result? I add x plus 7. So x plus 7 is 22. The way I solve this is that I want to leave x on the left hand side, so I subtract 7 from both sides, and I get x equals 22 minus 7. Therefore, x equals 15. I will then go and check. I think of a number, my number was 15. I add 7, 15 plus 7 is 22, so it is correct. Before moving on to continue modeling real-life situations using equations, a bit of terminology is required. We work in algebra with expressions and with equations. So we have expressions and equations. An expression can be something of the form 2x plus 1. This is an algebraic expression. It doesn't give you any information. Can be 3 times 5 plus 7. We call this an arithmetic expression because they are just numbers. X plus y minus 4z squared. This is another expression. Whereas equations contain an information. If we say 2x plus 1 equals 5, this is an equation. An equation always contains an equal sign. 1 minus 5x over 3 equals 9. This is an equation, contains an equal sign. Equation can be more simple or more complicated, but all equations contain an equal sign. We also have formulae. Formulae are particular types of equations. When we say that speed equals distance over time, this is a formula. A formula is a particular type of equation, contains an equal sign, see it is an equation, but generally contains more variables, in this case 3 variables, speed, distance, time, and this connection between them helps them find one variable when you know other. So formula is just a particular type of equation. The following examples are taken from the Pearson book, screenshot it here. Let us look first how we write some expressions, some algebraic expressions or numerical and algebraic expressions. So in this question, I'm going to solve exercise 3, and then we will pause a movie and do the others by ourselves and see the answers. For exercise 3, I'm asked to write an expression for the sum of 5 plus 7. The sum of 5 plus 7 is 5 plus 7. Here I'm just asked if I know the terminology and I can interpret a statement, write it into a mathematical statement. Question B, the sum of 5 and y, 5 plus y. The sum of x and y, x plus y. Sum means plus. Now we can pause the movie and write the other, solve the other questions. Here are the answers to those questions. How about you pause the movie and you try this question. A. If 3 lengths of rope, each 2 meters long, a graphical representation always helps. So each of them is 2 meters long, are cut from a 10 meters long rope. My diagram is not to scale. What is a portion left? So operation I'm going to do is 10 minus 3 times 2. I don't jump into calculating because in question B it asks me for a generalization. If 2 lengths of rope, each of x meters long, are cut from a piece of rope that is x big meters long, capital X, what length is left? X, take away 2x. And see, in algebra we make a difference between capital letters and small letters. They are different variables. See how the pattern here is followed here. Whatever I do with numbers, I will do with letters. You can pause the movie and try these 2 questions. And here are the answers. The expressions that we modeled before were not equations. No information was given from which I could find the unknown. Now we are moving on to modeling equations. It's the same process, just in the problem you need to look for an information that gives you the equations. In this problem, the information is here, giving you the equation. Result is 17. So my result equals 17. How do I get my result? A certain number, let's read from the beginning. A certain number, which I don't know, is multiplied by 3. Then you get an answer, and this answer, then 6 is added to the answer. And you get the result. You know the result is 17. Now see, you can solve this problem by doing inverse operations. So what would you do? You do 17 minus 6, inverse to multiply this division, divide by 3, and you'll find the answer. However, we should be able to write an equation from this because, as I said, later on the examples will be more complicated. So I will start by calling my number. Let x be the number that I'm thinking of. And I'm starting to model this information using the word x, the unknown x. A certain number is multiplied by 3. So x is multiplied by 3. Well, I will write this 3x in algebra. Then 6 is added. So 3x plus 6. The result is 17. And this is my equation. Now I focus only at solving equations. We'll solve equations in a later movie. But as you see, since it's done here, these are the inverse operations that I'm doing to solve this equation. So I take 6 from both sides, and I get 3x equals 11, and then I divide by 3 both sides, and my number is 11 over 3. Let us try to solve this problem. A rectangle is 3 times longer than it is wide. Very often a diagram helps. It is 3 times longer than it is wide. I will start. The most common mistake is that when students will say, let x be the width and y be the length. I have 2 variables. I rarely use 2 variables. I need to see a connection between them. What do I see? Or what am I told? I'm told that the length is 3 times as much as the y. So 3 times as much as the width. So it's 3x. I can write it as 3x. Now I continue reading. If it has a perimeter of 92, what are its dimensions? This is my equation. My equation is perimeter is 192. How do we find the perimeter now? I involve properties of shapes. So this has the length. So the perimeter is, remember I start from a point and I go around the shape. So x plus 3x plus x plus 3x is 192. And now that's an equation simple to solve. I collect like terms. I involve all the skills that we learned before. 8x equals 192. Divide both sides by 8. And I get x equals 24. Now I'm looking again at the problem. Did I answer the problem? What are its dimensions? So I need both dimensions. Width is 24 and length is 24 times 3. See, I have 3x, which will give me 72. And these are my answers. Please read this question. If 5 is subtracted from a certain number, let x be my number. Five is subtracted from x minus 5, and then that result is then halved. The most common mistake will be when students will put 5 divided by 2. If we think of both mass, in this case it will be just 5 divided by 2. But I have the whole result divided by 2. And here comes the information, give me the equation. Answer is 6. In algebra, we don't really use division, we use fraction. So my result is divided by 2. Then the answer is 6. That's an equation involving fraction. I would multiply both sides by 2 to get rid of the denominator. If you have half x minus 5, you double it to get x minus 5 equals 12. Then we add 5 to both sides. So get x equals 17. And this is my number. And this is our last problem for today. In a class of 32 students, it is known that there are 6 more boys than girls. Well, we have in the class boys and girls. Many people will start with let B be number of boys and G, for example, be number of girls, or X and Y. You can choose whatever letters you want. A class has 32 students. Boys plus girls is 32. Well, what do I do next? I have 2 variables, boys and girls. I can have 1 plus 31. I can have 2 plus 30, and so on. There are many possibilities. But, and as I said, those students will feel here stuck because they missed a bit of information. There are 6 more boys and girls. So boys and girls are related. Yeah, the number of boys and girls. If we think of a representation, yeah, there are more boys and girls. So for example, if this is a number of girls, this is a group of girls, there'll be 6 more boys than girls. So boys are the same number of girls plus 6 more. And this one will be boys. Altogether, there are 32. Now see how it makes sense, because I can express everything in terms of number of girls. So I will say let X be the number of girls, or B, or G from girls, be the number of girls. Then there are G plus 6 boys, because I know that there are 6 more boys than girls. It's not 6 times, but it's 6 more, means plus 6. And here it counts my information. The class has 32 students, so is not the use is not used here to give me the information, but it's hidden. The class has 32 students, meaning that, if you want, together there are 32. So, number of girls plus number of boys is 32. How do I solve this equation? Collect like terms. Take away 6 from both sides. Divide by 2. So there are 8 girls. And there will be 8 plus 6, 14 boys. Oops, it's not a class of 32. So let's see how I'm checking, and I'm going back. If I add them, it's 22, not 32. Where is my mistake? So going back, 32 minus 6 is actually 26. Therefore, I will have 13 girls and 13 plus 6, 19 boys. Adding them together, indeed, I have now 32, and I have 6 more boys and girls. So always go back and check your answers to see if it verifies all the conditions of the problem.